In 2025, something entirely unexpected unfolded deep within one of Google's most advanced quantum research labs. Hidden behind layers of security and chilled to near absolute zero, quantum processors were being used not for typical simulations, involving particles or molecular interactions, but for something entirely different. This classified experiment focused on a machine drifting silently through the vast emptiness of interstellar space. Voyager 1, a spacecraft launched decades ago and now over 15 billion miles from Earth. With its nuclear batteries gradually losing power, Voyager was reaching the end of its long mission. Yet rather than simulating physical decay or a routine system failure, the results of this quantum simulation revealed something profoundly unsettling. The engineers expected to see a simple, predictable shutdown as Voyager's systems failed. But what emerged from the simulation defied expectations. According to two insiders who agreed to speak anonymously, the patterns in Voyager's signal degradation weren't random. Instead, they were happening in synchronized intervals, suggesting a kind of entanglement-like behavior, something entirely unexpected in a spacecraft governed by classical physics. Voyager's transmissions appeared to be reacting to something, raising an alarming question. What could possibly be influencing a spacecraft that isolated, that far from any known objects? This led some theorists to consider whether Voyager was encountering forces or phenomena in deep space that humanity had never detected. Even more unsettling was the thought that something might be observing the probe, changing its behavior in ways that couldn't be explained. The simulation pointed to the idea that Voyager wasn't just dying out. It was somehow reacting to external stimuli. And then, just a few weeks after these unusual findings quietly circulated among a handful of researchers, something truly unprecedented happened in real life. Voyager 1 experienced a sudden, unexplained malfunction. The probe began transmitting data that made no sense, streams of garbled, unreadable noise. NASA's Jet Propulsion Laboratory spent weeks trying to decode the signals, but couldn't make sense of any of it. Eventually, they traced the issue to a corrupted section of the probe's memory. Specifically, part of its flight data subsystem had inexplicably failed. On the surface, it looked like the kind of issue that could be blamed on decades of wear, cosmic radiation, and the extreme conditions of deep space. But for those familiar with the quantum simulation, the timing was chilling. The glitch happened almost exactly when the simulation had forecasted an anomalous signal event. It was such a precise match that it no longer felt like coincidence. This led to a deeply troubling possibility. Had the simulation predicted the failure, or had it somehow caused it? The line between prediction and causation was beginning to blur. If simulations could predict real-world malfunctions with such accuracy, it could revolutionize space system engineering. It might allow scientists to anticipate system failures, years or even decades in advance. The implications for AI diagnostics, deep space mission planning, and interstellar exploration were extraordinary. But there were also disturbing philosophical questions. Could observing a possible future actually make it more likely to happen? In quantum mechanics, measurement itself affects the system. Could something similar apply to classical systems when examined through quantum computational models? Was Voyager's fate set in stone, or had the act of simulating its end nudged it toward that outcome? These weren't just academic debates anymore. They were diving into the deepest questions about reality, consciousness, and the role of observation. If quantum simulations could influence outcomes rather than just forecast them, then what else might have already been modeled and unknowingly nudged into reality? Officially, neither Google nor NASA acknowledged that such a simulation had taken place. When questioned about quantum computing applications in space exploration, both organizations gave vague answers, mentioning only theoretical research. But inside the research community, the reaction to Voyager's real-world glitch was swift and decisive. Some engineers involved in the project quietly left their roles. Others were reassigned. Access to the simulation systems was revoked. And, perhaps most telling, all data related to the simulation was completely deleted from Google's internal systems soon after NASA's public announcement about Voyager's malfunction. There was no technical justification for the deletion, no mention of storage limits or routine data management. Those who asked were simply told that this line of research was not to be pursued any further. It was a quiet but thorough shutdown. The speed and scope of the data purge suggested something more than routine caution. It felt like suppression. Someone had decided that the results of the simulation were too sensitive to keep. But why? Why would a computational forecast be considered so dangerous that it had to be erased? What did the simulation truly show that disturbed decision-makers to such a degree? And most unsettling of all, who had the authority to make that call? To understand the possible implications, it's important to look at how quantum simulations actually work. Quantum computers, such as Google's Sycamore processor or its more recent Willow chip, are designed to simulate the behavior of quantum systems, electrons, molecules, and exotic particles. They excel in solving problems in fields like material science and complex chemistry, where traditional computers fall short. But Voyager, like most spacecraft, operates in the realm of classical physics. Its systems are based on predictable engineering and known physical laws. However, there's a growing frontier in hybrid computational methods, where classical data is fed into quantum models to detect complex patterns. This approach has found success in areas like financial forecasting and weather prediction. In systems with countless variables, sometimes subtle correlations emerge that classical analysis alone can't reveal. This might have been the method applied to Voyager. The Voyager program itself is one of humanity's greatest engineering feats. Launched in 1977, both Voyager 1 and 2 were originally designed for a 4-year mission. Yet they've been running for nearly 5 decades, powered by radioisotope thermoelectric generators that slowly decay over time. They've now left the heliosphere and are venturing through true interstellar space. Each year, engineers shut down more instruments to stretch out the limited power as far as possible. By 2026, another major shutdown is scheduled, marking one of the final phases of the mission. Whether the quantum simulation was just a strange coincidence, a brilliant breakthrough in predictive modeling, or something we never should have explored, it's clear that we've entered a new chapter, where simulation, prediction, and reality are beginning to overlap in ways we don't fully understand. The technology we're building to understand the universe might be powerful enough to influence the phenomena it observes. The idea that a quantum computer could accurately simulate, or even influence, a spacecraft 15 billion miles away raises profound questions, not just about science and engineering, but about the very nature of time, causality, and free will. Voyager 1 is still drifting through space, its power slowly fading. The true cause of its glitch may never be confirmed. The simulation logs are gone. The researchers have been reassigned. Official records show nothing unusual occurred. But the implications haven't disappeared. They echo in labs and quiet conversations among those who saw what the simulation revealed. We may have crossed a line without realizing it, a threshold where technology no longer just observes the universe, but begins to shape it. Voyager might be the first casualty of that shift. And if this is true, we must ask ourselves, what have we already simulated that might still be waiting to unfold?